Greetings. My name is Mike Levis, and I'm an instructor with the Mount Hood Ski Patrol Avalanche program. The topic of this presentation is safe travel planning in avalanche terrain. So the point of this module is to answer this question. Would you ski this slope? If so, down what line? If you're ascending this slope, how do you do this safely? How can you use the information you've been gathering to pick routes up and down the mountain safely? Our learning objectives in this module are listed on this slide. Let's briefly go through them. When you've completed this module, you should be able to A. Identify factors that influence route safety, identify generally safe route choices, identify generally unsafe route choices, and demonstrate safe route selection practices. Safe route selection starts with the homework you did planning the trip. This should look familiar. It's the bullseye model that we discussed in the stability assessment module. Your safe route selection process starts with the analysis of the AVI triangle variables. You then will apply this information to route alternatives. You can refine these route selection alternatives as you narrow and improve your bullseye data. This slide shows an example of a tool you might find useful, particularly in conjunction with CalTOPO's slope angle capability. This slide shows avalanche paths from previous avalanches, in this case for Cottonwood Canyon in Utah. In our route selection process, we need to know if we're going to be traveling in terrain that has a history of avalanches. Ideally, we would pick routes up and down the mountain to avoid these areas. If this tool doesn't cover the area you're going to be traveling, use CalTOPO. Identify slopes greater than 35 degrees or wind-loaded slopes and avoid these areas if possible. Many of you are familiar with this. It's the Forest Service danger scale. So what does this have to do with route selection? Well, based on the conditions, you may need to reduce travel risks. For example, if the rating for the day is considerable, maybe look for lower slope angle paths for additional safety. You can trade off risk and slope angle. Higher risk, go to lower slope angle routes, or go do something else entirely. So let's discuss some general principles for safe route selection. First, you need to have the right equipment and you need to know how to use it. This includes an AVI transceiver, shovel and probe, inclinometer, map and compass, GPS, emergency shelter, and the 10 essentials. Make sure you've practiced with the equipment and know how to quickly and effectively deploy in an emergency. If you've borrowed someone's beacon, make sure you know how to use it. For example, is the display in meters or feet? Secondly, only travel with properly equipped people. One person without a beacon or probe places the whole group at risk. Thirdly, know and be realistic about your group's ability. Everyone should be comfortable in all the terrain you'll be traveling in. Fourth, know the terrain to be traveled. What are the slope angles along the route? Are there any terrain traps? Are you on the lee side of ridges that could be heavily wind-loaded? Fifth, plan alternative routes. If snow stability tests indicate unstable snow, you need to go to plan B. Number 6, if your bullseye data is looking questionable, go do something else entirely. Go see a movie or some other activity. Come back later when the conditions improve. Lastly, and this is really important, have a common understanding of the risk you're willing to tolerate. Discuss safety decisions and have common understanding of go, no-go decision criteria. Misalignment on risk tolerance can lead to poor decisions and create unnecessary conflict in the group. So you've all arrived at the parking lot, grabbed your skis, and you're ready to take off. What do you need to do before you hit the slopes? Well, first, a beacon check is mandatory. We will demonstrate these on the field day, but generally beacon checks need to check that each person's beacon is turned on, works in transmit, works in receive, and is in transmit mode when they leave the parking lot. Secondly, do a quick check of the weather. Does the weather in front of you match the weather forecast? Is the weather stable, degrading, or improving? And lastly, dig a pit as soon as practical to get a sense for the snowpack structure and any weak layers. As we travel, we want to do everything possible to avoid high consequence exposure. Remember all the points discussed in snowpack stability and terrain assessment? This is where we put that knowledge to use. Do we see any signs of instability? For example, recent avalanches. Are we traveling on or below slopes in the 35 to 45 degree range? Everyone in the group should be encouraged to discuss any safety concerns at any time during the trip. Discuss safety issues openly. Discuss options for reducing risks and how to make decisions. We will talk more about algorithms for decision making in more detail in the Human Factors module. At all times, be flexible. Be ready to change your plan and objective based on the current situation. So let's discuss some general rules of thumb for identifying safe terrain. This slide lists some considerations for choosing safe terrain. Let's discuss these in more detail. As we go through these, try and think of the areas you ski. Do any of these considerations apply? Have you been choosing the safest routes? The windward side of ridges offers a reasonably safe avalanche route on most mountains and most risk conditions. The windward side of the ridge will have much thinner snowpack and won't suffer from the wind loading and associated avalanche risk on the leeward side. Note that in some cases the windward side of the ridge may be wind scoured with exposed rocks, so you'll have to navigate around that. And of course, be aware of cornices. Assume the leeward side of the ridge is corniced and give it a wide berth. In avalanche terrain, valleys are nothing but large terrain traps. Wide, U-shaped valleys offer the safest option. Travel down the center of the valley if possible to avoid exposure to any slide on slopes to the right or left. If the valley is narrow and V-shaped, try and get up high above any potential slide to minimize risk. Usually the downwind side of the valley will have the least wind loading and will be your lower risk. The bottom of the narrow V-shaped valley is high risk in any but the lowest risk categories. Timbered slopes can offer some safe route travel alternative if the trees are tightly packed. Of course, tightly packed trees may not be passable without a lot of difficulty, so if this is your best option, it may be time to think of another plan for the day. Trees that are more widely dispersed offer no safety and in fact would be a hazard in the event of a slide. The avalanche in this case would strain you through the trees, resulting in a lot of trauma. It's important to know the risks of the immediate terrain you're traveling on, but it's equally important to know the terrain around you at all times. What are the slope angles of the terrain above you? If it were to slide, what would be the consequences? What are the safest travel options? Are there cliffs or forested terrain below you? What would be the consequences if a slide were to carry you downhill? How can you minimize these risks? So let's discuss more specifically some rules for reducing the risk while ascending a slope. Many of these rules will also apply when descending as well. First, never cross above another member in your party. If you trigger a slide, they may well be in the slide path. As we mentioned previously, follow the windward side of ridge lines. Try and traverse high on ridges well above any potential avalanche paths. And as always, assume all leeward ridges have cornices until proven otherwise. Generally, when we're crossing potential slide paths, we want to travel one at a time from safe zone to safe zone, following the same track. If the snow stability is a concern, stick to low-angle slopes. Avoid terrain traps for the reasons we've discussed previously. So now that we've reached the top, how do we find a safe route down the slope? Many of the rules for safe descent shown in this slide are the same as the rules for safe ascent. When departing, we want to ski one skier at a time from safe area to safe area. Avoid skiing above other skiers. Keep in sight of each other at all times. If we're descending down a gully or a slide path, we want to stay along the flanks to avoid getting caught in any slides. As we move down the slope, we want to plan escape routes to use in the event of a slide. This slide shows an image of a safer descent. Note the skiers traversing the slide path one at a time from one safe area to another safe area. While one skier is descending, the others have eyes on the skier to make sure they can track his route. Note no one stops in the middle of the slope. The person keeps going from one safe area to another. The skiers traverse in the same track and always have an escape route in mind if there's a slide. So what's going on here? Do you see any problems with this? Have the skiers followed the rules outlined in the previous slides? We'll talk more about this in the lecture. This slide lists some areas to be avoided when traveling in avalanche terrain. We want to be hypervigilant when we're on or below slopes that have a slope angle greater than 30 degrees. For the most part, we want to avoid these slopes in all but the most stable conditions. Lee slopes, as well as ridges or slopes with cornices, should be avoided. And of course, avoid terrain traps. Also, be cautious around rock-snow interfaces. As we've discussed previously, these are candidates for fracture points in a slide. So if skiers follow these rules, why do people still get caught in avalanches? Well, first of all, people don't always follow the rules, and there are some other common mistakes that I'd like to point out. As we've mentioned previously, you can trade off risk with slope angle. As conditions degrade, your route selection should focus on lower angle slopes to reduce risk. So one common mistake is skiing slopes that are too steep for snow conditions. Another common mistake is not reading the slope correctly. Slopes can be very complex with multiple convexities that have very localized slope angles that could exceed 35 degrees and can act as a trigger point. Slopes with multiple start zones create a unique hazard. Ideally, you should avoid these slopes since a slide could be triggered at multiple locations. Also, selecting a route with limited islands of safety or a slope with limited visibility to keep eyes on other skiers increases risk and should be avoided. So this slide and the next 2 or 3 slides show slopes that have various kinds of risks to travel. What I'd like you to do is look at each of these slides and identify routes up and down the slope. Use the rules we've discussed in the previous slide. Come prepared to present your route selection rationale at the next class. So for example, on this slide, you can see we've gone ahead and identified some unsafe areas and some safe areas. So I'd like you to be able to articulate why the unsafe areas are unsafe and why the safe area is safe, and be prepared to discuss that in our next session. Likewise, on this slope, you can see some ski tracks there in the safe terrain. Again, identify areas that would be safe travel routes up and down the slope, and we'll talk more about it in the next session. Likewise here, you've got a nice gully. How would you get up and down this safely? Please come prepared with some ideas on how you might do that. This is in the Wallowas, so I think that's a nice steep slope to the right there that people like to ski down. So how are we going to get up and down that, and what are some things we might want to avoid? So that brings us to the end of this module on safe travel and route selection. During our field sessions, we'll go on a tour and practice applying these techniques on the slope. Thanks for your time today.